Hey guys, so this lesson is on adding and subtracting rational expressions with unlike denominators. This is actually what we worked on during our last class. If you remember, we didn't do any practice with this yet. We just did notes. We did, I think, all of the front, and then I'm gonna do all the back now. Before I start, I will do a few from the front just to refresh your memory. Okay. So actually, before I start this, I'm just gonna off to the side. Let's do an example of adding or subtracting with like denominators. So let's say I gave you this x plus 3 over x plus 1 plus 2x over x plus 1. So this is what we practiced for a couple days um, last week, and we did it with like denominators. So remember, these bottoms are the same. When you have like denominators, you can just add or subtract the top. So for something like this, since these x plus 1 and x plus 1 denominators are the same, we can just simply add the top. So we're really just doing x plus 2x. You want to combine your like terms. So x plus 2x would give us 3x. And then 3 isn't like with anything. So we'll just rewrite that. Remember that when you're adding, the denominators do not change. They stay the same. So you have this after you add the top. Now we have to see, well, can this be simplified? So notice the top we can take out a GCF. So we can take out a 3. And then you'd have x plus 1. And then the bottom you'd have x plus 1. And then finally, you want to see if there's any repeated factors that you can cross off. X plus 1 and x plus 1 are gone. And then for this one, your final answer would be 3. So that's what we learned how to do when the denominators are the same. Last class, we started talking about what happens when they're not the same. So adding and subtracting just like fractions in general, like up here, when the denominators are not the same, remember you want to ask yourself, like say example 1, we want to ask yourself, what's something that 4 and 2 both go into evenly? And so it's 4, so that's your common denominator. So remember, like the left one stays the same, and for the right one, you want to think about what do we multiply 2 by to get 4? And it's 2. So you multiply 2 by 2, and you have to do the top by 2 also. So this becomes 1/4 plus 6/4. Once you get your denominators the same, then you just add or subtract the top. So this would be 7/4. That can't be simplified, so you would just leave it as 7/4. Okay, I'm going to do a couple more of the ones we already did. I'm going to do these evens. So number 2 we already did before, but just as a refresher, we have 4c and 2c. So this is kind of similar to the one we just did. To make these the same, we can make them both 4c. So this 4c on the left is going to stay the same. And then, so that's going to stay the same. This 2c, to make it a 4c, we're going to multiply by 2. So do the bottom by 2 and the top by 2. So this becomes 9 over 4c plus 6 over 4c. Once you get your denominators the same, then you just add the tops. So this is going to be 15 over 4c. And that would be your answer. Okay, so there's that. Let's do number 4. This one has expressions on the top. So for this one, we have 6 and 30. Oh boy. 6 and 30. To make those the same, we can make the 6 a 30 by multiplying by 5. So I'm going to multiply this by 5. And then you have to multiply this entire top by 5. So basically, you're going to distribute a 5 to both of those. So this is going to be 5a plus 50 over 30 minus 2a minus 1 over 30. Okay, so since we have those denominators the same, now we're just going to subtract the top. So remember, when you are subtracting, you have to distribute a negative to both terms. And so what I mean by that is this is going to now become a positive, and the negative is going to go here and here, changing this to now positive 1. Okay, once you distribute that negative, then you can combine like terms. So we're going to combine 5a and negative 2a, which is going to be 3a. And then 50 and 1, which is 51. Okay, so we have 3a plus 51 over 30. Now that we have that, you have to try to factor it. So this numerator, 3 and 51, we can take out a 3. 3 goes into both 3 and 51. So if we take out a 3, that's going to be a plus 17 over 30. And then lastly, the 3 and the 30 can simplify. So that's going to be a 1 on the top and a 10 on the bottom. So then I guess your final answer will right over here would be a plus 17 over 10. Okay, so there's your answer for number 4. We're going to do one more on the front before we go over to the back. So example 6. Now, when you have ones like this, if you look up here to these directions, I wrote factor the denominators only. That's only if the denominators can be factored. So far, the examples I've showed you, the denominators could not be factored. But now we've gotten to one, number 6, where this right here, this can be factored. If you remember, that's called the difference of squares. They're both perfect squares. It's subtraction. So if one of your denominators can be factored, you do want to factor it. Oh, boy. Okay, hold on. I forgot to lock it. One moment, please. Okay, sorry about that. So we do want to factor that. So this is going to stay the same. This one we're going to factor to w plus 2, w minus 2. Okay, so w plus 2, w minus 2. So now we want to look at over here, we have w plus 2, which we have that here. But on the right side, we also have a w minus 2. So that means we have to make these denominators the same. We're going to multiply the left one by w minus 2. And that would make the denominators have the same things. So now see how we have w minus 2, w minus 2, w plus 2, w plus 2. That's what you want. You want your denominators to be the same. Since I multiplied the left by w minus 2 on the bottom, I have to multiply the top by that also. Okay, so this left top becomes, we're going to distribute this w to both of them. So you have w squared minus 2w. On the bottom, you have w minus 2, w plus 2. Then we have minus 8 over w plus 2, w minus 2. Okay, so now we have to just subtract across. Notice none of these are like terms. So this, I'm going to write over here, becomes w squared minus 2w minus 8 over w plus 2w minus 2. So this is kind of a long one. Some of them are like this. So now we have to simplify this. So now you want to ask yourself, can that numerator be factored? We want numbers that multiply to negative 8 and add to negative 2. So it's going to be 4 and negative 2. So this becomes w plus 4, w minus 2, and then the bottom, w plus 2, w minus 2. Notice we have w minus 2 on the top and the bottom, so those can cross off. And then our final answer would just be w plus 4 over w plus 2. So that was kind of long for sure, but some of these like in between steps you don't necessarily always have to write. Okay, so let's go on to the back. These are the ones that we haven't done. Okay, number 7, this one's actually just like the one we just did. This right here is a difference of squares, so that can be factored into k plus 3, k minus 3. Okay, so now over here on this bottom right, we have k plus 3, which we already have over here. We need a k minus 3, so we're going to multiply by k minus 3 on the bottom and on the top. Okay, so the left side is going to become 6k for the top. And then we're going to have k squared minus 3k. I'm sorry, I have to let my dog out. Get go. Bye. Okay, sorry about that. So then we have up here, we're distributing this. So that's where the k squared minus 3k comes from. So the bottom is just k plus 3, k minus 3. Okay, so now, actually, I'm going to rearrange the top. We want the top to be in standard form. So actually, I'll just rewrite it. It's fine. I'll write it over here. So the top, we can actually combine the 6k and the negative 3k. That would be 3k. So the top becomes k squared plus 3k over k plus 3k minus 3. Okay, the top actually can be factored. We can take out a k, right? They have a k in common. Okay, so we took out the k. So now notice the k plus 3 and the k plus 3 are gone. And so we can write our final answer. I'll write it down here, which would be just a k on the top and then a k minus 3 in the bottom. Sorry if this is a little bit messy. Kind of takes some getting used to. So that would be your answer. All right, that's example 7. Pause it there for a sec. All right, let's take a look at number 8. So again, if your denominators can be factored, you want to factor them. So notice that this one, a plus 1, obviously cannot be factored. So this one can, because that's a trinomial. So we want numbers that multiply to 5 and add to 6. So that's going to be 5 and 1. So this bottom is going to turn into a plus 5 times a plus 1. Because 1 times 5 is 5, 1 plus 5 is 6. So this bottom right one, we have an a plus 1. What do we need? We need the a plus 5. So that means we're going to multiply by a plus 5 in the bottom and the top. Okay, so if we're multiplying 1 by a plus 5, that's really just going to be a plus 5. Because if you think about like distributing that, that's 1a plus 5. So the numerator here is 4a and then plus the a plus 5. The bottom is just your a plus 5 and your a plus 1. Okay, so now on the top, we have to combine these like terms. So that's going to become 5a plus 5 over a plus 5, a plus 1. Okay, so before we finish, we have to simplify. So we want to think about, can this numerator be factored? Yes, it can. We can take out a 5. So I'll finish that over here. So once you take out a 5, you should have a plus 1 inside the parentheses, because remember, you're dividing both of them by 5. And then the bottom is a plus 5 times a plus 1. Okay, lastly, we want to cross off any common factors. So the a plus 1 in the top and the bottom, those can go. And then you're left with this. So your final answer is 5 over a plus 5. That would be your final answer for number 8. So you're just factoring the bottom if it can be factored, figuring out how to make them the same, multiply, add or subtract the top, and then simplify at the end. Okay, let's do a few more. So number 9. Number 9, again, you only want to factor the denominator. Even though this numerator here can be factored, you don't want to factor that quite yet. So if you have stuff in the numerator and the denominator that can be factored, you don't want to factor both. You only want to factor any denominators. So I right now am only going to factor this. We want numbers that multiply to 8 and add to 6, which is 4 and 2. So this is going to turn into g plus 4 and g plus 2. So then compare that with just a g plus 2. So you have to ask yourself, well, what do we need? We need a g plus 4 because there's a g plus 4 on the other side. So we're going to multiply top and bottom by g plus 4. Oh boy. Sorry, it's going to take some getting used to. Okay, so g plus 4 on the top and the bottom. So now we have to distribute this 3 to the g and to the 4. So this left side is going to be g squared plus 4g. And we're going to add to that the 3g plus 12. And then on the bottom is just a plus 4. Oh, it's a g. Oh boy. G plus 4, g plus 2. Okay. Next, we need to combine like terms on the top. So these two middle terms can be combined. So over here, we're going to have g squared plus 7g plus 12. And on the bottom, g plus 4 times g plus 2. Okay, so that's what happens after you add the numerators. Now we just have to factor the numerator. So remember, after you add or subtract the numerators, you need to see if it can be factored. So now we want numbers that multiply to 12 and add to 7, which would be 4 and 3. So now that turns into g plus 4 times g plus 3. And then the bottom, we have g plus 4 times g plus 2. Last step, we need to cancel the ones that are the same, so those are gone. And then our final answer here, kind of ran out of room, but this is your final answer. G plus 3 over G plus 2. Okay, let me see which ones. I don't think we really need to do all of these. There's a lot more. Okay, we're going to skip number 10. We're going to go to number 11. I'm skipping 10 because on the practice, there are not any like that. So I'll go back to that if we need to. Okay, number 11. Notice actually both denominators here can be factored. This one has a GCF, so does this one. So our first step is to factor the denominators. So over here, I'm going to take out a 2, and I'd have r plus 4. Over here, I'm going to take out an r. Let me get rid of these lines so they're not confusing. Over here, I'm going to take out an r. Oops. So we have r, and then r plus 4. Okay, so now let's compare these denominators. Notice the r plus 4 is common, which is great. The bottom left has a 2, the bottom right has an r. So all that means is to make these the same, the bottom left needs an r on the bottom and the top. The bottom right needs a 2 on the bottom and the top. So remember, anything you add to one side and the bottom, let's say, has to go to the top as well. So on the left, our numerator is r squared. Our denominator is 2r and then r plus 4. This is minus, there's a 16 on the top. Because 8 times 2, oh boy. 8 times 2 is 16. And then this denominator is 2r and r plus 4. Okay. Next, we have to subtract the numerators. Typically, you would distribute this if it was 2 terms, but it's not. So we're just going to write r squared minus 16. So I'll continue this up here. So r squared minus 16 on the top, 2r times r plus 4 on the bottom. So next we have to factor the top. The top is a difference of squares. So that turns into r plus 4, r minus 4. And then the bottom is your 2r and the r plus 4. Notice the r plus 4 is on the top and the bottom, so we can cancel those. And then lastly, our answer is just an r minus 4 in the top. Sorry. r minus 4 in the top, and then a 2r in the bottom. That cannot be simplified any further because it's a monomial in the bottom. Okay, so for number 12, notice that the top left and the bottom left both could be factored, but remember you only want to factor the bottom. So this bottom, we want numbers that multiply to negative 45 and add to negative 4, which are going to be p minus 9 and p plus 5. Okay, so notice we have the p plus 5 here and here. So now on the bottom right, we have the p plus 5, but we need the p minus 9. So we're going to multiply the bottom and the top by p minus 9. Okay, so this is what this turns into. We have p squared minus 9p, and then minus 2 times p minus 9. Then we have over p minus 9 times p plus 5. So this negative here has to be distributed to the 2. So we're taking a negative 2 and multiplying it here. So this is really going to become negative 2p plus 18. Once you distribute that negative 2, then you can combine like terms. So your like terms here are going to be the negative 9p and the negative 2p. So to rewrite that numerator, it's going to be p squared minus 11p plus 18 over, actually, I'm going to write this off to the side. I'm kind of running out of room here. Okay, so I'm going to write this over here outside the box. Sorry if you ran out of room on yours. So this is going to be p squared minus 11p plus 18 over p minus 9 times p plus 5. Okay, so now this numerator we can factor. So we want numbers that multiply to 18 and add to negative 11, which are going to be p minus 9 and p minus 2. Because they multiply to 18 and add to negative 11. Okay, so now notice we have a p minus 9 in the top and the bottom. Those are gone. And then this is our answer. P minus 2 over p plus 5.